going to briefly discuss about my poster which I am going to present. The title of the poster is Role of Mutual Information in the Page Curve of Hawking Radius. So, what is page curve? Page curve is nothing but the time evolution of entropy of Hawking radiation. So, in this curve, there are two kinds of entropy. One is the thermal entropy, one is the entanglement entropy of Hawking radiation. So at the beginning of the evaporation process, the thermal entropy of the black hole is the maximum, but the entanglement entropy of Hawking radiation is minimum. This is zero. So as time passes, the thermodynamic entropy decreases and entanglement entropy of the radiation increases. And there is a time when these two becomes equal, which is known as the page time. And after page time, what happens? The thermodynamic entropy becomes lesser than the von Neumann entropy. So this contradicts the unitary principle of quantum mechanics. So therefore, there is a paradoxical situation with after the page time. So to resolve this issue, we have a formalism that is recently proposed formalism, which is known as the island formalism. According to island formalism, the entropy of the radiation is given by this formula. So for our study, we have considered eternal black hole solution of 2D jetty gravity, which is coupled with a flat thermal bath. So in critical coordinate, the metric on the gravity side and the bath is given by this equation. And we also assume that the black hole spacetime is filled with 2D conformal matter with central charge C. After phase, so basically, there are two proposals in our work we have given. One is before phase time, one is after phase. So before phase time, there is no contradiction. Therefore, we have suggest that we have therefore there is no island contribution. So we have proposed that in this time domain, the mutual information between the matter field r plus union r minus depicted by the green line is vanishes. So this gives us a particular time which is known as the Hartmann-Maldacena time. So basically at Hartmann-Maldacena time, this mutual information between r plus and r minus vanishes. On the other hand, after page time, where actually the paradox appears. So after page time, the island starts contribute to the entanglement entropy of Hawking radiation. So in this scenario, we have proposed I B plus union B minus vanishes. That basically mutual information between the B plus union B minus vanishes. This implies this condition gives us Ta minus Tb equal to some finite time, which is nothing but the scrambling time. But in earlier work, it was shown that Ta equal to Tb, which is not correct according to the Penrose diagram. Now we will proceed to find the position of the island. To find that, we add the area term and extremize the entropy with respect to the island parameter A. This gives us this result given in this box. Now, if you now using this result, we can again obtain the entanglement entropy of the radiation, which comes out to be time independent, and that is why that's what we require for eternal black hole. And we have also find the page time by equating this thermal entropy of the black hole and the entanglement entropy of the black hole. Now, we not only find the leading piece in both leading piece of entropy, we have also find the subleading corrections, and in the page time we will do the same. So, in summary, just after the page type, inclusion of island gives us the rho b plus union b minus equal to rho b plus tensor product rho b minus. This leads to the disconnected phase of entanglement wedge corresponding to b plus union b minus. The island separates the entanglement wedge of b plus union b minus. I b plus b union b minus equal to 0 happens when the time difference is equal to the scrambling time, and I b plus union b minus equal to 0 yields a time independent expression of SR and eventually leads us to the correct page curve. So these are the reference which is followed to make this poster, and these are a couple of papers we have published regarding this work.